Hello and welcome to another video. This will be the part 2 of depth sensing module, and basically those of you who've already seen the part 1, they know the basic background theory of how this prototype is working. Basically this was my final year project, and I am uploading this video for my official university page, and this will also be available on my YouTube page, but you can also see this on my university page, that is Concepts University Islamabad. I will drop the link if I found it. Right now I don't know the link where they will upload this video, but I will definitely find it soon, and I will let you guys know that too. And this will be the descriptive video that will cover both the aspects of part 1 and part 2. So those of you who haven't watched the part 1, they will be having good idea behind this prototype. So this was um, this was the final year project, design of a low-cost depth sensing module, and basically this is the poster that we were supposed to be presented on Comsets CPCE, but still this video is basically for the. I hope this will be shared for CPC, virtual CPCs, so that's why I'm showing you guys this poster. And this was the basically agenda of our project, that was abstract. Um, right now we already know that visual computing is increasing day by day, and on current scenarios we can see that using of depth sensing modules are huge in some of applications, such as I have a number of applications in my mind, and some of these are basically let me show you what is the depth. Basically this is a depth sensor. This is Kinect, which was the motivation for this FIP. And what Kinect is, basically it is a single based camera depth sensor. It has an IR sensor and it has a single camera, and it gives the depth perception on the base of IR signals that are being reflected back to the camera. So it is like single camera based depth sensing modules are basically a lot more accurate than stereo camera based depth sensing module, which was our prototype. We used two cameras, and um, we basically re-implemented the human behavior in those cameras, like just like how human eyes see the environment, and how the human intercept the depth of an object. We basically re-implemented that scenario, you can say that theoretically, and that was completed, of course, alhamdulillah. And basically stereo cameras are not more accurate, but they are still do the job. They still do the job. They are usable outside the home environment. They are usable in sunlight, etc. Kinect is not usable in sunlight because its sensor is so much sensitive it can be fried up. And there are a lot of touch sensing module examples, such as anti-spoofing face recognition, basically face recognition, you all know, I hope so. Face recognition nowadays is very much common. Let me just come back. Okay, where were we? Yes, face recognition. Yes, face recognition is very much common nowadays. You can see it anywhere, and the basic difficulty in implementing face recognition for home automation is that basically face recognition is a system that can recognize a face, but it will recognize your face or your image as well. So you cannot be so sure about the security measures if you implement it for your for automating the door of your home. that is for home automation, because someone can open your door by using your photograph, which is a dangerous move. So anti-spoofing face recognition is a type of systems that already exists, but uh, they uses different scenarios. There are different principle for developing and diffuse spoofing face recognition. And one of them is using a depth feature, which is using a depth sensor. By using depth sensor, we can basically predict the human face very well. We can see that there is a nose and there is a depth of a nose on the human face, so we can basically predict the real face and the image. Fake image means not fake image. I mean like spoof attack, like human similar face image. So we can discriminate between that. And what I did was I basically used deep learning for developing. Basically, first I developed a depth sensor, which was stereo. And then I used a dataset. I collected dataset using my own depth sensor, and it was like, let me show you. Not here, not here. Yes, it was like 30,000 for training images and 13,105 for validating data. And basically for testing, I basically implemented it for an application, so it does not need testing data because it is real-time testing and it is far more accurate than I expected. And the accuracy was like, this is the training accuracy, the orange one, and this is the validation accuracy. And the training accuracy was like 99.86 something, and the validation accuracy was 99.443, I'll guess. I don't remember exactly, but it was. And these were all the um, trained models previously I trained. And I basically trained almost 250 models. And after 250 models, I was able to train a model which can classify a real human face uh, with a image of a same person. So, and then I implemented that into a recognition, which in turn can be uh, can be labeled as anti-spoofing face recognition system. Also, there are examples for self-driving robotic car, driver assist, and also there are driver assistant systems and augmented reality applications, such as augmented reality are very common in virtual reality gaming. Also, they are used in 3D user interface. For self-driving car, there is an example of Tesla autonomous cars, Model S and Model S3, S2, whatever. They are all using depth sensors for their automatic driving system. Also, this was literature review. I will not go through that. Yeah, you got the basic idea. So, visual computing has been increasing day by day, and you can see that too. And for that, there are already available depth sensors. There are a lot of depth sensors available, but the the problem is that in Pakistan they are very much costly. You can see this. This is the price comparison of uh, this prototype and with other prototypes, and there is a huge barrier of prices. This is like uh, two times greater than this value. So this is also very expensive. This is also three times expensive. This is four times expensive. So when our prototype was like 14,750, including Raspberry Pi and two RGB cameras with tripod stand. So there is the thing we designed was low cost depth sensing module. And after that, for application, basically, what you say that yeah, uh, yeah, anti-spoofing face recognition system for application, for potential application. This is basically the block diagram, which is also over here. Let me just do it here. And okay, yeah, this was our agenda that we will design a low-cost depth sensor, and this was basically completed on 7th semester, I guess. Alhamdulillah. And then we moved towards the application and a GUI implementation. So this is the basic block diagram. I hope this is visible enough. Yeah, I will. Yes, you can see this from here. Basically, there was a stereo camera module which was designed using two webcams, and there were I designed three prototypes, and this was the fourth one, which I included, which was basically the final prototype. And this is basically two webcams, and they are fixed in a manner that their internal lens is on the same line. If you draw a line from a scale, or if we draw an imaginative line, we can say that they are parallel to each other. And for stereo depth sensor, we have to make sure that both for both cameras, the lenses of both cameras should be parallel to each other. For the more they are parallel to each other, the more they will be good enough to perceive the depth of an environment. So basically, this was implemented on Raspberry Pi, and Raspberry Pi was is behaving as a client. I wrote a software for Raspberry Pi to act as a client. For in the software, it is basically um, capturing stereo frames. You can call them stereograms also. It is sending over the server, that is computer in my case, PC, and it was on PC. There was a GUI. There is a GUI that I will show you at now again, and the GUI is predicting for a person as recognition, also as anti-spoofing recognition. That is, it will see whether it is a real face or it is a non-face, anti-face. That is in my case, and also it will predict whether it is recognized or not recognized, and it will basically the application was in the motivation of opening a automated door for home automation. So it is basically opening the door in the GUI, as well as there is a secondary door that I will not show in this video, but you can see that in my previous video. I will leave the link below in this video. And the automated door was connected with Arduino, and Arduino was connected with Bluetooth modem, and along with the servo motor, which was used to control the automated door. I will not go through that. Yeah, this is basically the depth. This is disparity, and this is the depth. And I will explain it later what is the difference between disparity and depth. But the major difference is that there is an RGB scale over here for understanding this depth. The more the red region is, the lesser will be the depth. So this is the more red, and this is indicating that this is a face, and in face this is closer to the camera as compared to this. So this is anticipating that it is a human face. And on images, it will not anticipate it like that. See over here? Yeah. It is detecting it as a face, classifying it as a face using the model as an anti-face. And this is a depth scale. Now towards the running prototype. Yeah, this is over there. Why is it? Okay, let me relaunch the client. I guess it's stuck. Wow, my laptop is stuck. Anyway, this is a GUI and this is a basically server. And thing that is happening that it is receiving from another laptop. I don't have any Raspberry Pi right now, so I'm running it using a laptop that is being stuck right now, sadly. But the overall behavior is that it is receiving from the laptop, and the GUI is basically uh, percepting the depth, and it is making a decision whether the door should be open or not using uh, using anti-spoofing model that I trained and recognition model that I am using. The behavior is like, let me show you this. This is a stereo camera client and receiving frames, that is server, and there are two buttons. Yes, there are buttons. Click to verify and click to close. And if the button is pressed, then thing that will happen, it will is see if whether there is a face detected, and if no, then it will go back to generate color disparity, and if there is a face detected, then it will apply recognition and spoofing model, and if the button was pressed, then it will detect also face. It will repeat the scenario. Yeah, there is a lot of code backend. um, I can't explain it in a single video, sorry guys. But still, I'm trying my best. So if the face is not detected, it will definitely go to generate color disparity. If the face is detected, it will recognize the face. If no, then again results will be displayed. If yes, then it will apply 15 predictions. Yeah, it will apply 15 prediction, and then results will be displayed. And on those 15 prediction and recognition of 15 prediction of face anti-spoofing model as well as recognition, it will open the door if there is a yes from it, and there will be yes if it is a real person and if the person is registered in recognition model. So I hope you guys get a basic idea. uh, I'm hoping that the one might now. Let me see. Oh great, oh great, wow. Okay guys, the problem is that, yeah, the problem is that this is not a problem, but because this is a huge code and it is using a database for recognition, so it takes some time for running, for launching up. So I will show you the depth perception from another code that I wrote. Then I will definitely show this by removing the my dataset. And after that, the thing that will happen is there will be low prediction for the recognition model. But right now I will do that to show you guys. Yeah, let me just change the tolerance. Where is the tolerance? Tolerance. Yeah, there it is. 0.6. Yeah, 0.6. And then I will use my dataset in order to make it run quick. Okay, sorry guys. Things happen, bad things happen sometimes, but we are good. Mm-hmm. We are definitely good here. Where is my FIP folder? Okay, yeah, here it is. Here it is. I have a lot of code and it's hard to manage right now because I'm seeing it like straight after 3 to 4 months. I haven't seen it for a long time. Yeah, I will delete this dataset. It was my friend. I don't need him anymore. Yeah, and then I will delete from this to this and all dataset, and it will run faster. as expected. Okay, but first I will show you the depth perception. Where is the depth perception? Yeah, there it is. Okay, and now let me run again the client. Okay, client, be good this time. Great, it's running perfect. Okay, let me just explain you step by step what's happening and how that is being percepted, and then after that I will show you the application and the whole product itself. Um, let me see how much time has been passed. Okay. Oh my god, 30 minutes. Okay. Okay, here's the thing that is happening right now. You are seeing basically a video stream of two cameras, stereo cameras. Okay. Um, how would I? Stereo camera. I don't have another webcam, and but I have the video of this in my previous video. You can visit that too if you are interested, and that is connected to the Raspberry Pi. Right now it is connected to the laptop, and I don't have another webcam, so I cannot show you guys this. But still, okay, this is a video stream, and right now you are seeing that they are not stereograms. In stereograms, we have to make sure that the same pixel in both of these images should be on same axis. But here you can clearly see that this is let's call this pixel as an black pixel for me, and let's call this as a brown pixel. Now the black pixel over here is not on the same axis as this black pixel. This black pixel is right now. Okay, in images we have from here we have maximum value of y-axis, and from here we have zero value of x-axis, and from here we have maximum value of x-axis, zero value of x-axis, and from here we have, I hope you guys are seeing my cross, your here cross mouse, mouse cursor. Here there is a maximum value of x-axis. So the black pixel over here is not on the same axis as this black pixel over here, and this black pixel should have more a greater value, this times greater value, in order to be on the same axis. And for this there is a back-end coding, and I will not explain that. I don't think there is enough time, but after rectification this will happen. The same pixels on both images would be on same axis, and all left to do will be calculating the x-axis difference, and from that we can calculate the disparity, and from disparity we can percept the depth. There is a lot of concept backend concept, but still I'm trying my best, guys. If you guys still had and curious, you can reach me on my email. I will upload another video. I will definitely upload another video. It needs more explanation, I guess. But here you can see that, okay, this is a black pixel, and this black pixel is on same axis as compared to this black pixel. These two black pixels are same, but there is only x-axis difference, so I will calculate the x-axis difference. Okay, guys, I want you all to do some exercise. That is, place your finger over here, and right now I'm considering this frame as a wall. Consider a wall and find a spot and pick your finger over there and see it from one eye and then from another eye. You will see the displacement of your finger, right? And then bring your finger closer and repeat this again. You will see also different, but the difference is that from here you will notice the greater distance, and from here you will notice the lesser distance. And basically disparity is that noticeable difference, and the greater the disparity means that the noticeable distance is greater, and the noticeable distance is greater, therefore it is less depth. The greater disparity is, the lesser will be the depth, and the lesser the disparity is, the greater will be the depth. So this was the principle that I used, and this is the disparity basically. It is in grayscale, so the more the value is towards the 255, the more white it will be. The more white region is indicating that the disparity was greater. That is why on calculating the difference we have greater. So this is my hand, and this is also my hand, but this hand is like lesser gray as compared to this. This is more white, so this has greater disparity, indicating that it is having a lesser depth. Yeah, and again, this is a color disparity view for a better understanding. You guys, I hope you guys understand. Right now, you guys will remember the thing I told you about. The more red region is indicating the more lesser depth. Right? I I followed this. In most of depth sensor, this is the principle they use for RGB scale. The more the red region is, the lesser will be the depth. So this is basically far. This is my face. Okay, let me show you the depth. Okay, this is a hand and this is a hand, and you can clearly see that it is orange. It is red, so it is red and it is orange, so it will have less depth as compared to this. This is closer to the stereo camera as compared to this hand. Now this hand is closer to a stereo system as compared to this hand. Again, with my face, you can see my what you call it, nose, and you can see the depth of my nose. That is, it is more red as compared to my face, whole face. So it is clearly showing me that I have right now my nose is closer to the camera as compared to my face, and this will not happen in case of images. That is how I am classifying between image and a real person. Okay, let me show you another cool UI that I designed for this project. So the dataset I used for training my face and diffusion model was that I collected was both grayscale image and what do you call it, color disparity. Yeah, a grayscale disparity and color disparity, and that is how I collected far more data than I was before doing. Before the set. I was like training my deep learning model on 2000 images, and it was a huge mess. Yeah, it was a huge mess. Yeah. For deep learning model, we are required with a lot of data set. The more the data is, the lesser the fine tuning you will have to do. The lesser the data is, the more the fine tuning you will have to do. You can train a deep learning model on less data, but you will have to fine tune your model a lot more. A lot more. Yeah. Okay, it's not. Okay, great. I guess I have opened the wrong window. Where is my FIP? Yeah, my Python stuff. And where is my FIP? Here is my FIP. And here is my GUI. And I hope this works. Yeah. Come on. Okay. Refreshing the console. It is using IoT principles, so it's using the address of my IP. That's what happens if you rerun on the same address a new program. I was hoping to convert this into a exe file, but there were some hidden libraries. What do you call it? Yeah, what do you call it? Hidden libraries issue. Yeah, hidden libraries issue. So I will definitely do it because running. Oh yeah, it's launched. Great. Okay, let me press escape for. Oh yeah, I remember. I have to refresh. Oh, yeah. Okay. So here you can see that it is waiting for the client right now, and when I am running the client, it will run. Yeah. Great. Yeah. Okay. Okay. Here is the FPS because it's using two deep learning models, face recognition and face anticipation. And my system does not have any GPU, so definitely it will. It will, and also face detection. But face detection is not being done on using deep learning. but still it is using some memory. So yeah, without detecting the face, it will have more FPS, like almost 7 FPS sometimes. But on detecting the face, here is my face. Oh, right now I deleted my dataset, so it will not recognize me very well. But still, the main thing is like face anti-spoofing water. It is giving me face, and let me show you guys. And this is anti-face. See, isn't that cool? This is same. This is me. This is the face, and this is anti-face. And yeah, and this is depth perception. This hand is closer to the camera as compared to this hand. Now this hand is closer to the camera as compared to this hand, and there is a color scale right below. The nearer part will represent the redder region. Okay, so this code is uploaded on GitHub. I will, yeah, I will share the. Oh, great! Someone forked my. Yeah, code. Okay, I will share my GitHub page. I will not share this because there is also a website which is explaining this project in case you are good at reading. So you can read all this stuff. And there is a video, previous video, and I will give the link of new video here too. And this is all the explanation how to use my code. And yeah, I will share this too. Okay, guys, thank you very much.